Hello, Ramya. What about others? At least Vishnu.
Good evening, sir. I think he will join. I'm not sure, sir. I'll ask him, sir.
Yeah, please. If now we'll go continue. So have you gone through any problems?
Sir, he is joining, sir. Yes, sir.
So you don't have any doubts or any other?
Initially, we had some doubts, sir, but when we go through the solutions, it is okay, sir. We are able to understand.
Are they within the scope of what we have discussed or outside the scope of what we have discussed?
No, sir. What we have discussed only they have given, but there are many statement questions, sir. That is very difficult to answer.
Those will come from the practice only. Those are not at all an easy kind of thing.
Yes, sir. There are many statement questions, but that is very difficult to answer for us. Problematic, okay, sir. That is somewhat okay only. Sir, there is one question, Betty's reciprocal theorem. There are some questions from that, sir. Please teach us that.
Yeah, it's and that we can discuss. That's not take much time.
Okay, sir. There were around 4 questions from that topic, sir. Rest all what we discussed only it was there, sir.
Actually, we have covered all the
questions. I'll go through it, sir, and then we will ask any doubts, sir.
Yeah. Actually, what are the important topics are there that we have already covered? By this Friday, most of the important topics will be covered.
Okay, sir. Okay,
so
sir.
It's just like a small topics that are left over, like arches and all. There are very few actually. It's not of much important.
Okay, sir.
Yes, Prince, you can ask me.
Sir, actually last session we discussed about the symmetrical section, sir.
Yes.
And frame. Yes. We didn't. I couldn't understand that sum, sir. You just explained it orally.
If it is symmetrical, we'll just take off of the frame and then we'll solve it. That's it. Nothing else will do.
No, sir. That was continuously 2 sections, no, sir. In between a line was there.
In between?
The last symmetrical section, it had 2 frames continuously at symmetrical frames.
Yeah. As we told that wherever the symmetric line joins, we have seen that the slope will be equal to 0 there, isn't it?
Yes, sir.
So where the slope
will actually this question I can understand, sir. The next sum in slide number 180, 189, sir.
Just reload it. Actually, as there are nearly 200 slides, just taking time. Yeah.
Yes, sir, this sum, sir.
Yeah, whatever. What's the issue actually? As we have seen, this is what your symmetric line, isn't it?
Yes, sir.
This is what your symmetric line, obviously, at this point, the slope will be is equal to 0. Isn't it? If the slope is equal to 0, then you can idealize this joint as fixed support.
Fixed support, okay.
Yeah, and then you carry out the thing, whatever you want to do.
Okay.
It's just the same thing that we have discussed, nothing else.
Okay, sir. Then for member FC, what it will be, sir? For member,
you try it out first. You carry out the moment distribution method, and then we'll discuss on the next class. First, you try it. Still, wherever you're facing problem, just forward it to me. We'll discuss. Even in the next class, no issue. Okay.
Okay, sir. Okay.
So let us continue with our discussion. Now, imagine if I'm applying a force P, or imagine that this is what my degree of freedom 1. Let us see the properties of the beams are A, E, F. Can you guys tell me what is the stiffness A1? What is the type of the load given? Axial load, right? If it is axial load, we know what is the deflection? PL by AE, right? So if we replace this diagram, then K by delta can become less AE by L, right? So the axial rigidity of the beam can be defined as AE by K. Sorry, actually today there is some problem with my internet. That's why this is now. I think we already know. What about if I am considering this as my degree of freedom? What? What will be my stiffness? This we have discussed already. R&D is fixed. What is the degree of freedom? We are considering here rotation. If R&D is fixed,
4EI by L.
right? Now, similarly, if this is the degree of freedom, one, can you tell me what is my
2EI by L.
what will be our stiffness in this case? It's like sinking of support, isn't it? By an amount delta. Can you tell me what can be the stiffness here?
6EI by 6EI.
Now see the thing here. Imagine. So what is the type of support we are discussing here? Vertical shear hinge, isn't it? So here, what about the slope? 0. What about the axial deformation? 0. What will happen? It will only sink. Let us imagine it's sunk by an amount delta. We know the fixed end moments, isn't it? What are the fixed end moments? Can you identify the direction of the fixed end moments? Here it will be anti-clockwise. Here also it will be anti-clockwise. What is that magnitude? Fixed end moments that are developed due to sinking of supports are nothing but 6CA delta Y. Right? Now, let us find out the other reactions too. What is the net moment acting on this beam now? What about the net moment? Here also anti-clockwise, here also anti-clockwise. What about the net moment?
12EI by delta by L.
Right? Are there any other loads acting on this beam except the sinking of the core?
No, sir.
Right? So if there are, whatever may be the case, always the beam is stable, it has to satisfy the equilibrium equations, right? So how can this can be balanced? 12EA net moment is 12EA delta by L square, that is acting in the anti-clockwise direction. Then they can be balanced by using the vertical reaction. They should make which reaction? Clockwise movement. So for clockwise movement, here the reaction should be upward. Here the reaction should be downward. What about the net moment? So what about the reaction? The reaction will be, if you can remember, the net reaction will be net moment divided by length. What about the net moment? 12EI delta by L square divided by length. So what is the reactions there? 12EI delta by L cube. So here the vertical reaction will develop. Here is nothing but a 12EI delta by L cube, and here it will be 12EI delta by L cube. Now see, if you're talking about the stiffness, always you have to talk about the force corresponding to that direction only. Now, what is the direction of the degree of freedom that I have mentioned here? Along the vertical direction. But if I ask the stiffness, what you guys have told me? You guys have told me that 6CA delta by L. The degrees of freedom is in the vertical direction, but you told me the movement degrees of freedom. No. So what about the force corresponding to that direction? 12EI by L cube. So what is the stiffness? That is 12EI delta by L cube. That means if you want to move this in a vertical direction by an amount delta, how much force you have to apply? 12EI delta by L cube. Or else, how much fixed end moments they will develop? 6EI delta by.
Yes, sir.
Is it clear these cases?
Yes, sir.
Right? So these are just a small background. Now, let us start with some basic problem. Let us say that we are having the simply supported beam. And imagine that we are having this is the degree of freedom 1 and this is the degree of freedom S2. As we have discussed yesterday, what will be the size of the stiffness matrix? What is the size of the stiffness matrix here? It is always
3
degree
cross
of, right? Degree of freedom here 2.
Two
That's
reasons. Two schools.
2 by 2, isn't it? Now, if I write down the matrix, it is K11, K21, K12, K2. What we discussed, if I'm talking about Kij, whatever the first one represents, always
Force.
represent the numerator. K is nothing but a force required per unit deformation. If you are writing out in the formula P by delta, that means the first one always represents the force. And the second one always represents the displacement. So every time it will be the unit displacement. Right? Now, if you look at the first column, what about the second value here?
Displacement.
That means if you want to find out the first column, where you have to apply the unit displacement, you have to apply the unit displacement corresponding to degree of freedom 1. Similarly, if you want to find out the second column, where we have to apply the unit displacement corresponding to the direction 2. As of now, I don't think you guys have doubt. Now, how should I find out the first column? So if you want to find out the first column, the first step you have to do is that restrain all the degrees of freedom except degrees of freedom 1. That means if you want to find out the first column, restrain means do not allow the displacements of other degrees of freedom. And then what you should do? And then you have to apply the unit displacement corresponding to the degree of freedom 1. This is the second step that you should do. And the third step is that find the forces. So what is the first step? If you are finding the first column, you have to restrain all the degrees of freedom except that direction. If you are finding the second column, that means except 2, you have to restrain all of them. And then apply the unit displacement. And then find the forces required or generated. Now, for this simple problem, let us say we want to find out the stiffness matrix. Let us say we are interested in find out the first column. What is the first column values? K11, K21. So as I told you, what is the first step you have to do? If you are finding the first column, you should allow the displacements corresponding to the degree of freedom 1 only. Others you should not allow it. Now, that's fine. Now tell me, how can I avoid the second degree of freedom? What is the degree of freedom here? Rotation. How can I doesn't allow it? By considering artificial fixed support. See, if I imagine here it is a fixed support, am I allowing will it allow any rotation?
No, sir.
No, sir.
If you are finding the first column, what you have to do? Here there are only 2 degrees of freedom, right? So if I want to find the first column, what you should do? You should not allow the second degree of freedom. If I don't want to allow it, I have to make some changes at the support so that it will not allow it. So which support I can keep it there?
Fixed.
Fixed support, if I can keep it, it won't allow, right? So what is the next step? We have to apply the unit displacement. What is the direction here? Rotation 1. That means apply the unit rotation. To apply the unit rotation, how it will deflect? It may go deflect like this, isn't it? What is this value? I am considering theta 1 is equal to 1. Now, if I want to rotate it by 1, can you tell me how much force I should apply here?
4EI by
After
X.
rotate by 1, it will be, I need to require 4EI by
ODI by
right? If I am applying a force here, obviously as far and I am treating it as a fixed, moment will be carry forward, isn't it? How much moment will be carry forward?
2EI
half
by
of,
EI by.
half of the moment.
Now tell me, what about K11 then? What does K11 represents? If you apply unit displacement corresponding to 1, what is the force required or generated at 1? Look at the force generated direction along that path. It will be
4EI by L.
right? Is it along the same direction or opposite direction? What
Same
if
direction.
we are flowing on clockwise? The force is also on the same direction. So that's why positive. What about Q1? If I apply unit rotation at 1, how much force is generated at 2? What is the magnitude?
2EI by L.
Is it on the same direction or opposite direction?
Same direction.
same direction.
What is the magnitude? 2EI by L. Is it okay? In this case, it's just a simple case, isn't it? What is the second thing? If you want to find out the second column, which one you will not allow?
First subtotal.
First degree of freedom.
First article.
If I artificially create a fixed support there, that means as we discussed, it won't allow any rotation. What is the next step? Apply the unit
Apply
rotation. Is it right or is it the correct way of presentation or wrong?
Correct, sir.
Degree of freedom I have considered. Unit rotation I have applied in which direction?
Anti-clockwise, sir.
That means always remember the unit displacement you have to apply corresponding to the degrees of freedom direction only. If I consider my degree of freedom as clockwise, you have to apply unit displacement along the clockwise. If I consider there it is anti-clockwise, you have to apply it in anti-clockwise. That means initially, whatever the direction you will represent, along that direction only, you have to apply the unit displacement. Initially, I have considered as a clockwise. That's why I will apply the clockwise rotation.
Okay.
And then how the reflected shape will be? The reflected shape will be like this.
Okay.
Again, how much will you require if I want to move it?
4EI by
formula
L.
is a fix 4EI by L. Similarly, as it is a fixed support, half of them will carry forward. So how much?
2EI.
Now, what about K12? If I apply unit displacement at 2, what is the force generated at 1? I have
2EI
applied
by
unit displacement at 2. What is the force? EI by L. Is it along the same direction? 1 degree of freedom clockwise. Here also it is clockwise. So what is this magnitude? 2EI by L. Similarly, what about K22? I have applied unit displacement at 2. How much force generated at 2? 4EI by L. In the 4EI by. So finally, what will be my stiffness matrix? Okay, that will be equal to K11, K12, K21, K2. That will be equal to, as we obtained, 4EI by L, 2E into 2E into 4E into. Right? As from this, you can understand the stiffness matrix will always be symmetric. This you can prove it by Maxwell's reciprocal theorem that we'll discuss later on. Always remember that it will be symmetric, and always remember that the diagonal elements are always positive. They will be always positive. It doesn't matter. That means Why? Because is that if I want to rotate it by an amount clockwise direction, obviously I should apply a force on the clockwise direction only. That's why diagonal elements are always be the positive elements. So that's why if you are talking about the K matrix, it will be always symmetric and it will be positive definite. What is positive definite? I think linear algebra might have completed to in your mathematics. I don't know. The determinant will always be the positive. It won't be, there is no eigenvalues possible if you take the stiffness matrix. So at least is this okay? How we have to generate the stiffness matrix just for now?
Yes, sir.
At least a basic, right? Now let us start doing some examples. Or let me ask you some simple question. Imagine if there is a magnitude of 20 kilonewton meter. Let us say this is A and B. Can you tell me what can be my slopes A and what can be my slope B? How can I apply the stiffness method that we have discussed? For the stiffness method that we have discussed, can you tell me how can we apply? We apply or cannot? We need to find out rotationality and rotation. Can you tell me how to apply this formulation? What is the relation that we have to consider? Stiffness times displacements will be equal to the
Displacement force.
right? Now what will be my stiffness matrix? We know. Expand this one, delta 1 and delta. And here it will be F1 and F2. What will be the degree of freedom? Let us say that I am considering this is my degree of freedom theta 1 and this is my degree of freedom theta 2. Now, by looking at the diagram, what will be the corresponding forces corresponding to the degree of freedom 1? What is the force corresponding to the degree of freedom 2? Look at the degree of freedom 1. What is the force corresponding?
Melting.
Is it along the same direction or opposite direction?
Same direction.
That's why the magnitude is 20. And what about at theta 2? Is there any force acting at that joint?
No, sir.
No, right? So F2 will be 0. What is our requirements? Our requirement is to find out delta 1, theta 1 and theta 2. Those are what this theta 1 or delta 1 or delta 2 represents. So theta 1 and theta 2. Already we are having the stiffness matrix. Then what I should do? I should take inverse of the stiffness matrix times what is my value? 20, 0. So if I further simplify this, what I can write it down? I can take EA by L common, right? Now what is the magnitude here? 4, 2, 2, and 4. Can you quickly tell me what is the inverse of this matrix? What is the inverse of this matrix? Come on, quickly.
Modulus K divided by
What about EA by L? Will there be any change in EA by L?
it will be L by E.
Yes, sir. L by E.
Right. Times 1 by
Ma-
minus
Modulus of
1 over
K.
12. And what about here?
Minus 2.
Minus 2, minus 2.
Right. What about this K inverse? I have told you. What is the K inverse?
Flexibility.
Flexibility. So what will be my flexibility? L divided by 12 EI times 4 minus 2 minus 2, 4. So if K can be found, then flexibility can also be found by taking the inverse of the matrix. Now what you should do? You should just simply substitute that matrix here and then you will get theta 1 and theta 2. Is it okay? What is the application?
Yes, sir.
Instead of writing theta 1, get my percentage as degree of freedom 1. Now can you tell me stiffness matrix will change? Is it same problem or not? Is stiffness matrix still the same or different? What are the stiffness matrix that I have considered here? Can I consider the same stiffness matrix or not? Is it clear my question?
Hmm.
Can we consider the same stiffness matrix or not? Just think about it and tell me.
So same only, sir.
Same or not? What is the difference between these two cases?
Point load.
Point load.
Point load, right? The stiffness is depending upon material properties or beam type. Exact beam we are considering, degrees of freedom are also same. Then the stiffness matrix is also same. Why you took so much time? Theta 1, theta 2, theta 1, theta 2, that's it. Now can you tell me what about F1 and F2 in this case? What will be this value? What will be this value? Are you getting what I'm asking?
So WL by 6.
You? Please can you tell me?
So WL by 16.
Why we are facing difficulty to the right side problem? Why not on the left side? What is the difference? Can you identify? Differences can you identify?
So loading condition is different.
Yeah. In loading condition, previously 20 kilonewton meter, it is along the whatever the loading it is given in the first case, that is along the direction of the degree of freedom that we have considered. But what about in the second case? The loading, it is not along the degree of freedom that we have considered. Then how can we approach it? How can we approach this problem? What do you think the solution might be? So in my mind, I can think that here I consider my rotation as 1, and here can I consider there is another displacement coordinate 2, and there is rotation 3, and then there is rotation 4. So instead of considering at the joints only, I will consider 2 more degrees of freedom at the load that is acting. Then in this case, what will be my size of the stiffness matrix?
4.
4.
3 cross 3.
How many degree of freedom are there? 4. 4 by 4. Then what will be my force matrix? F1, F2, F3, F4. Now can you tell me what about the forces? What is the force given along the direction 1? Nothing, 0. What about the force given along the direction 2? 2 is along the direction of the force, P. Along the direction 3, 0. Along the direction 4, 0. If the forces are not there, then what I am doing? There also I am considering additional degrees of freedom, that is vertical and rotation. Obviously, we know, except at the supports and between whatever the point you consider, there will be vertical displacement and also there will be rotation. So this is about one vague way of solving this. What about the another way of doing this? What we have to do is that if the loads are not exactly falling on the degrees of freedoms that we have considered, then what we have to do is that we have to consider the effect of that load on the degree of freedom we have considered. That means I want to consider what will be the effect of this force along the degree of freedom that I have considered. Now, imagine that if it is a fixed support. Can you tell me what about the fixed moments that will develop?
Minus WL by A.
What is the direction? Anti-clockwise. Here also it will be clockwise. Now what about that value? PL by
8.
8, sir.
PL by 8 or PL by 4?
8, sir.
8, sir.
8. Are you sure?
Yes, sir.
I'm thinking PL by 4.
Fixed and moments, it is WL by 8.
WL by 8, sir.
PL by 8. PL by 8. Now, tell me, what is the moment at this joint if this is simply supported? What is the moment here at this point?
0.
0, right? What about the moment here?
PL by 8.
Why the moments are generated here?
Due to fixed support, sir.
Okay, due to fixed support, but what it is doing?
It is allowing
Why
the moment.
Here it is allowing the moment, that's why rotations are possible, but here
Restraint,
the
sir.
rotation
Restraint.
different. That means rotations are not allowed. That's why the moments are generated. Now, I will ask you one thing. Now, imagine that there is a point load P, and this is what the deflected shift, isn't it? What about the rotation here? Clockwise, let us say theta 1. What about the rotation here? Clockwise, theta 2. Isn't it? Now, here the clockwise rotations are possible. If I don't want the rotations here, as the rotations are possible in clockwise, whatever the resisting moment's direction, that will be in the opposite direction. That will be nothing but, let us say, some moment. Here also, if it is a simply supported beam, it will allow the rotation at this point. So because of the load here, anti-clockwise rotations are possible. To restrain it here, the clockwise resisting moments are developed. Isn't it? Now, let's say this is theta 1, right? Imagine what will happen if I apply a clockwise moment of M. Imagine there is a simply supported beam, load P, and here, if I apply an anti-clockwise moment of M here, and here if I apply an anti-clockwise moment of M here, can you tell me what will be my rotation at point 1 and what will be my rotation at point 2? Same simply
0,
supported load
0.
P. 0. Why? Because
It is cancelling the rotation.
yeah, that means how much movement that is causing the effect of theta 1 to get the possible rotation 1. How much movement is required at that joint? M1. To get the rotation 2, how much movement that is possible? M2. That means if there is a load P here, what I should do, what will be the effect here? In the form of fixed moments. Fixed moments will be developed in the anti-clockwise. So if I apply a moment here, M, and if I apply a moment here, N. Let me tell you one more piece. There is a simply supported beam. Now I will replace this value. Let us say this is M1, this is M2. M1 and M2. Now, if I apply this a magnitude of M1 here, and if I apply a magnitude of M2 here, this is 0.1 and 0.2. Can you tell me what will be my rotation 1 and what will be my rotation 2? Can I compare these two cases?
M1, M2, same.
Will they be same or will they be different?
Will be different, sir.
Different? Different or same?
Different.
Same, sir. Same only, sir. Because no load is active.
What I am telling you is that initially I have considered a simply supported beam, and because of the load P, imagine that these are your displacements theta 1 and theta 2. What I am doing on the second case, instead of the simply supported, I am treating them as a fixed. And what I am doing, I am evaluating the moments. This is what nothing but M1. This is what nothing but M2. Because of the same point load. Now what I am asking you, instead of the load, I am considering the same simply supported. And what I am doing, here I am applying this moment of magnitude M1 but in the opposite direction. Here M2. Now I am asking you, can I correlate these two or not? If I can correlate, what can be my theta 1 and theta 2?
M1 and M2, sir.
I apply the same
M2,
moment.
sir.
Same moment M1 and same moment M2 here. What will be my theta 1 and theta 2?
It will be equal to M1 and M2, sir.
Theta 1, these two will be the same, right? The rotation here, the rotation here. Also it will be the deflection. Theta 1 and theta 2 will be same. So it just like I am trying to convey to you is that if you treat the beam as a fixed end moment, fixed end at both ends, there will be fixed end moments you will consider. They are generated just because you are not allowing the rotation there. So if you are not allowing the rotation, fixed end moments developed are M1 and M2. If you want to allow the rotation, you have to apply the same magnitudes there, but in the opposite direction. So what I am telling you is that if the loads are not exactly acting on the degree of freedom, what you have to do is that in the present case, if this is the force P, if you imagine it is a simply supported, what is the moment that is generated? M1. Now here consider in the opposite direction. I am considering it as a clockwise. Here the fixed end moment generated in anti-clockwise. But here I will consider it in the anti-clockwise M2. Now if I idealize in the previous way, what will be my force F1? What is the force 1 direction? Clockwise. 2 direction clockwise. So what is the corresponding to force 1? M1. What is the force corresponding to degree of freedom 2? 2 is also in clockwise direction, but in anti-clockwise direction. So minus M2. Problem. You can find out rotation and rotation 2. That will be equal to K inverse times force matrix. What is the force matrix? M1 and minus M. So the thing I want to convey here is that if the forces are not aligning the directions we have considered or directions of the degree of freedom we have to consider, then what you should do is that obtain the fixed end moments and take the moments in the opposite direction. Those are nothing but your new force matrix along the degrees of freedom that we have considered. If you have any queries, let me know. These type of questions they will not ask in the exam. Why? Because I'm just telling you just out of curiosity, that's it. You might face this type of questions either in finite element method if you're having your degree right now or in the master's. Yeah. Can I give you one more thing? Think about it. Still if you have doubts, we can discuss in the next class also, no issues. Now, can you tell me what is the degree of freedom for this? What is the degree of freedom we have to consider? I'm asking you how much degrees of freedom you will consider here in this case. What is the degree of freedom at point A?
0, sir.
What about at B? It is a free
3.
end, right? It is
Three,
a free end that I can consider. I can consider horizontal, vertical, and rotation.
Vertical and rotation.
You can tell me, let us say I've considered vertical in downward direction, horizontal on the right side direction, rotation on the clockwise. You can consider in any direction, it doesn't matter. Okay. Now, what will be my stiffness matrix size?
3
What
class
will be
3,
my
sir.
stiffness matrix?
3 class 3.
Right. Now, I want to find out first column. So if I want to find out first column, what I should do? I should allow only the displacement corresponding to the degree of freedom 1. And other two, I should not allow it, isn't it? Now look at the joint B, and can you tell me which type of support I can place? Now tell me which degrees of freedom I should allow. Degree of freedom 1, I should allow.
Vertical.
What about 2? Not allow. What about 3? I should not allow. Now, if I don't want to allow degree of freedom 2 and 3, can you imagine and tell me which type of support I can place at B? Which type of support I can place? That only vertical deflection is allowed. Place vertical like this.
Vertical shear roller. Vertical shear roller, sir.
I can write. If I place like this, then it will allow only vertical. It won't allow horizontal. It won't allow rotation. Now, what is the next step? Apply the unit displacement, right? What is the direction we have considered?
Downward.
See the direction of degree of freedom 1. Downward, right?
Downward.
So, move this point to the downward by an amount. Let us say unit, or let us say some delta. What will be the deflected shape? The deflected shape will be somewhere like this. Isn't it? Now, can you tell me what the moments that will generate? We have already discussed, right? Here it will be, it has rotated in clockwise, so here it will be anti-clockwise. What magnitude? 6
EA.
square. Here also it will be in anti-clockwise, isn't it? How much it will be? 6 EI delta by L square. In addition to, are there any other forces will develop? They are not balanced, isn't it? What is the net moment? 6A delta by L square anti-clockwise, 6A delta by L square anti-clockwise. What is the net moment? 12A delta by L square. That means the reaction should develop in clockwise. Why? Because the moments are in anti-clockwise. So what about their magnitude? Net moment is how much? 12A delta by L square divided by length L. So what about this value? 12EI delta by L cube. Here also it will be 12EI delta by L cube. Other than that, any other forces? No, right? Any horizontal forces will develop.
No, sir.
Okay. Now, look at the values and tell me what about K11. Look at the direction 1. Is there any force that is acting along the degree of freedom 1? Degree of freedom 1 is along vertical direction. Is there any force that is acting along the vertical direction?
12 EA delta by L.
12A delta by L square. L cube.
You have to apply unit displacement. If you want to apply unit displacement, what about the delta value? 1.
1.
If you take delta equal to 1, what about the value?
12 EA by L cube.
Is it along the same direction or opposite direction?
Same direction.
That means positive.
Positive.
What about K21? What about the direction 2? Horizontal. Is there any horizontal force that is developing here?
No, sir.
Any horizontal force that is developed at joint B?
No,
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 sir.
sir.
What are the magnitude?
0.
What about K31? What about the 3 direction? Rotation. That means
Clockwise.
what is the moment corresponding to that? 6A delta by L square. If I take delta 1, 6EI by L square. What about the direction? Positive or negative?
Negative, sir.
What is the direction we have considered 3? Clockwise. But what is the moment that is generated here? Anti-clockwise. B minus. Is it okay? These 3 values? Is it fine? If
Yes,
these three
sir.
values are fine, then okay. Now let us go for column 2. Now similarly tell me, if I want to find out the second column, degree of freedom 1, we should not allow. Degree of freedom 2 only we should allow. Degree of freedom 3 we should not allow. Now see the diagram and tell me which type of support I can place at B such that only degrees of freedom 2 will be allowed, 1 and 3 will be restrained. What is that type of support?
Hinged, sir.
If it is a hinge is allowed, right? If there is a hinge, rotation is allowed or not? That means
Yes,
degree
sir.
of freedom 3
Sir,
is
yes,
allowed.
sir.
That is not the option.
Horizontal shear hinge.
Yeah, if I place a horizontal shear hinge here, it will allow only the degree of freedom along that. Now, if I want to move it by a unit displacement, how much force I should apply? It's like an axial force, isn't it?
Yes, sir.
Now, how much force will be required? As we have discussed, AE by.
L.
So, if you apply axial force, it is nothing to do with the vertical and rotation. If you apply axial force here, the restraint force will be developed here. How much it will be? AE by.
L.
Now, similarly, can you tell me what about K21? Sorry, K12, K22, K32? What about the force corresponding to direction 1? Is there any force developing along the 1? 1 is vertical. Is there
No,
any
sir.
force? No,
No,
right?
sir.
What about the value? 0. And what? How much force is developed along 2?
AEPL.
Yeah. What about the force that is developed along 3? Any moment that is developed
No,
because
sir.
of the axial force?
0, sir.
0. Clear? Now, let us come to third column. If you want to find out third column, then 1 we should not allow, 2 we should not allow, we should allow only 3. Now, which type of support I can place there? Which type of support I can place here? Such that 1 is not allowed, 2 is not allowed, only rotation is allowed.
The 6 is there.
Place a support like this. If you place a support, pin support, vertical not allowed, horizontal not allowed, only rotation is allowed. And apply the unit rotation, clockwise direction. Then this is what the deflector shape. How much force will be required here? For in this fix, how much force is required?
48.
Carry power will be there, right? What is the carry? 2E. Are they balanced? These two?
No, sir.
No, sir.
What is the net movement? 2E by L clockwise, 4EL by clockwise. If this net movement in the clockwise, then what about the support reaction?
And down.
Anti-clockwise. For
68
anti-clockwise,
by 68
this
by
should be in
square.
the downward. This should be in the upward. What about their magnitude? Net moment by what is net moment? 2A
68
by
by
L,
L.
6EA by
L.
divided by
S
L.
square.
How much it will be? 6EA by L square. Here also 6EA by L square. Now tell me, what about K13? What is the force corresponding to the direction 1? Look at this diagram and tell me what is the force corresponding. 6EA by
L square.
Is it along the direction of the degree of freedom or opposite to the direction of the degree of freedom?
Opposite to the direction.
Opposite. That means it will be negative.
Negative.
What about the force along 3? Along 2, direction 2. Is there any force along direction 2?
No, sir.
No. What about along 3?
48 by
here. That is along the same direction. Right? Now it's clear, right? It seems. So can you try any other problem if I give it? Now tell me what is the degree of freedom I should consider here now? In this case,
two,
what?
sir.
How many degree of freedom we have to consider here?
2, sir.
2, right? What are they?
Yes, sir.
Rotate B.
Theta B, theta C.
Can you try it? This problem now, quickly. Just take 3 minutes and tell me. Solve this and let me know. The answers. Imagine if I consider this as 1, if I consider this as 2, at least I can expect what is K11. Can I explain or you want more time? You want to solve it or you want me to solve it? That's fine. Let me tell you this one. At least have you got any value K11? If you can respond then accordingly, I will explain it to you.
4 ABL, sir.
How much?
4 ABL.
Okay, let's see. So if you want to find out first column, obviously what we should do? We should allow only 1, right?
Yes,
2
sir.
I should not allow. So in the
Yes.
place of which type of support I can imagine?
Hinge.
Rotation should not be allowed. So let us say I'm imagining fixed kind of support.
Yes, sir.
Okay. Now, at B, how many members are connected?
2 members.
Like in the previous case, only 1 member is connected, but here 2 members are connected. So if I want to rotate B by an amount 1, obviously what will happen? The connected members theta
Theta
BA
B equal to
must be
theta B.
rotated to 1 and theta BC must be rotated to 1. Now look at the BA part only. And if you apply the unit rotation, how it will deflected like this, right? Now, how much force will be required here for theta BA? What about the far end?
It's
Yeah.
like
Far end is fixed, how much is required? 4EI by L, right? 4EI. EA is given as A. What about the length 4? So 4EI by 4. That will be equal to, in the place of 4, we are getting it as. Now, look at this BC part. Again, draw the deflected shape. How it will look like? It will look like this, isn't it? Now, how much will be? How much moment will be required? Again, what about the far end? It is stated like a fixed support. 4EI by L. What about the A value? 2EA. So 4 into 2EI by length is how much? 4. 4 gets cancelled. How much it will be? 2EI. So to rotate both the members by unit rotation, total how much moment is required?
3 ABL.
3EI. L is already considered, right? So
Yes, sorry. 3.
3. See, if I am applying a moment here, obviously the moment will carry forward here. How much it will be? If it is EI, here it will be EI by 2. Now for BC, 2EA. Then how much will we carry forward? Half of it. How much? 2EI by 2. How much it will be? 2EI by 2. How much it will be? EA.
Yeah.
Now tell me. What about K21? What is the K21 value? Along the same direction here also. So what is this magnitude? E. Any doubt here in this case? Any doubt in this case?
No, sir.
So can you quickly try K121, K22? If you are smart enough without doing anything, you can tell me K12.
Sir, same only, sir.
What is K1?
K1, 3 A, sir.
K12.
Okay. Not EA, sir.
K12, 3A or EA?
EA, sir.
Yeah, what about K22?
E3A, sir.
Okay. Now, matrix here. You try it out and then I'll tell you. What is the size of the matrix? Already directly I have given you 2 only. So So quickly, can you try it in this case too? You can write simply in the same way.
Sir, this one little bit difficult. Sir, this one will be difficult to see.
What about A11? Yeah, okay, that's fine. Any answers from both of you? So tell me. So if I want to find out first column, then obviously, as only 2 are there, I should not allow 1, right? How can I make this happen? How can I constrain it?
By making safe support as hinged.
At B, which type of support I can place? I can place this type of support, isn't it? That means rotation is allowed, but not the displacement. So apply unit rotation. How the deflection will look like? Clockwise, isn't it? Again at B, how many members are there? If you want to
2
apply
members, sir. 2 members.
theta BA. Now look at theta BC. What is the far end? C. What is the type of support? Pin support.
Pin
If far
support.
end is pin, how much force we have to apply to the unit rotation?
3A by 1.
3A by
Yeah.
L is like is L, 3A by. What about for theta BA?
4A by 1.
4EA by
Yeah.
right? So total how much? 7EI by.
7A by 1.
So I can directly know what about my A11? That will be equal to 7EI by L. Now I think you guys might have problem in the A21, isn't it?
Yes, sir.
Now for that, let me separate this. Can I consider like this separately as a given structure? Now here how much moment we are applying? We are applying here how much? 3EI by L. Is there any carry forward movement to the opposite side?
0, sir.
0, right? So what about the other values? Are these balanced or do we have to balance here? Net moment is 3A by L and clockwise. We have to balance it. How do we balance it? By reaction. Here it will be in the downward. Here it will be in the upward. So what about this magnitude? If total length is L,
L square.
3A by L.
L square.
why? Here it will be 3I by L square, right? Similarly, what about the moment in this case? Here it will be clockwise. What is that magnitude? 4EI by. What about the opposite? Far end, fixed. Moment will
Yes,
carry
sir.
forward or not?
Yes, sir.
Yes, sir. Forward, sir.
Here also it will be
Half of the
4EI, sorry, half of it 2EI by. What about the net moment?
6
Clockwise, 6EI by. Then how can I balance it? Reaction,
Anti-clockwise.
isn't it? Reaction should make clockwise or anti-clockwise?
Anti-clockwise.
anti-clockwise.
Anti-clockwise. Here it should be left side. Here it should be, isn't it?
Yes, sir.
Sir.
Now what about that magnitude?
6
6E
L.
3A by L.
Now tell me what about K21? Look at this side and look at this side too. In this, is there any force corresponding to direction 2?
Yes,
In
sir.
the
In the opposite direction.
direction 2? No. What about in BA? What about the force corresponding to direction 2?
68 by L.
A by L square. Is it on the same direction or opposite direction?
Opposite direction.
Minus 6EI by. Is it okay? This problem, any doubt?
Yes, sir. Yes, sir.
Yes, sir.
Right. Now do one thing. Similarly, find. Tell me K11 and sorry K12 and K2. So which type of support I can place at B?
Horizontal shear.
Right. So try it. Let me know after you're done. Let me know. Any answers, guys?
K120, sir.
I'm telling you, this will be symmetric. If K21 is minus 6A by L square, then K12 will also be the same, isn't it?
Yes, sir. Yes, symmetric.
So let's discuss. So what you have to do? You have imagine that you have placed a here inside. Now, what will be the deflected shape? Here the rotation is equal to 0. That's why the members will deform like this, isn't it? Let us imagine this distance is delta r equal to 1. Now, if you look at this, will there be any contribution in the member BC? Imagine that if it is moved to the right side, what is the type of support that I have placed here?
Rollers.
If it is placed as a roller, will it allow any deformation?
No, sir.
No, right? That means this BC will simply move away. Whatever the resistance that comes from the BA only, isn't it?
Yes, sir.
If it is moved by a delta, obviously we know this is rotating clockwise. So what about the fixed moments? Here it will be anti-clockwise. Here it will be, and how much they will be? 6EI delta by L square. So let us say L square. So here it will be 6EA by L square. They should be balanced, isn't it? Anti-clockwise. That means how can them balance? Clockwise, isn't it?
Yes, sir.
So clockwise, this should be right side. This should be. So whatever the value, it will be 12EI by L square. Here it will be L. Now tell me what about K12? What about the rotation that is developed? 6EA by L square. What is the direction we have considered? Clockwise. But here how much it is generated? Anti-clockwise. So minus 6EA by L square. What about K22?
12
12.
EA.
So I think I don't know where you guys have done the mistake in this case. This is clear now.
Yes, sir. Yes, sir.
Now think about this case and can you tell me where the change can happen? If I am given like this, where can you see the change? The same problem, but what I have done, instead of roller support, I have placed it as a hinge support. So what do you think you will expect a change?
Delta will be in both sides.
So here we are, in this case BC, there will be additional force will also develop, isn't it? So what is that force? AE by L. Isn't it? If this is in, if it not moving, then if you want to move it by unit displacement, obviously this will also will resist. If this number is resist, how much for what is the stiffness? By L. So instead of 12A by L cube plus resistance from BC, that is nothing but AE by L. Have you got it? Why it will affect? In the previous case, it is a roller, so that will simply move away. But now, as we are restraining it, obviously, BC will also offer resistance. How much it will offer resistance? As it is an axial, AE by L. Yeah?
Yes, sir.
Yeah, can I give you one more case? As you are solving it for the first time, you are doing very good. So do not think that. Now, in most of the cases, what we will do, we will consider them as infinitely rigid. That means EA is equal to, EAE will be is equal to infinity. Imagine if I'm applying a force like this, P. Let's say the column is everywhere it is EA comma L. Here also it is EA comma L. Can you tell me what will be the reflected shape? If I am considering this as axially rigid, what can be the deflected shape? If you apply a force, then the deflected shape will be like this. So what will happen? This beam will simply move away from its position. If this is by an amount delta, this will also be by an amount delta. So can you tell me what is the stiffness for this case? If I want to move it by a unit displacement, How much force should apply? How much force we have to consider?
68.
Now imagine it is like thinking of support, isn't it? This as support by an amount delta. Now if you take the left side column, fixed moments will develop in. What about their magnitude? 6 delta by the support reactions. To balance it, here it will be right side, here it will be left side. So how much it will be? Delta by LQ. This is for left side column. What about for the right side column? For the right side column also it is same. So what about the total value? So what about the stiffness? If you are talking about this column here, how much force is generating? 12 EI delta by LQ. Here also how much will generate? 12 EI delta by LQ. So total what is the force? To move the left column, how much force is required? To move the right column, how much force is required? 12 EI delta by LQ, 12 EI by delta by LQ. What is then 24 EI by LQ. I consider delta is equal to 1.
1.
Any doubt in this case? If not, then I'll give you one more example based on this. So go through, let me know if you have any doubt on this case. If not, I'll give you one more simple example. Can I?
Yes, sir.
Don't know what you should do. Sorry. It is a straight column. Don't think that it is inclined column. Imagine that here also the axial rigidity is infinite. Sorry, axial rigidity is infinity, and my degrees of freedom considered high. Here this is 1, and here this is 2. Tell me what will be my stiffness matrix. Instead of 1 floor, I have given it here 2 floors. I think you can tell me K11. That's not difficult to find out itself.
So K11
24 EUA.
11? I could not hear you. What is K11? Whether it is right or wrong, let me know. Let me hear and tell you. I think you guys can tell me easily K11. I don't think it's a big deal. If you treat 2 as a fixed one, like if you don't allow any displacement at 2, isn't it the case like that we have discussed already, single story?
Yes, sir.
Like, so what is the K11 then?
24 EUA.
For EIBL, what about K21? What about K21 then? Is it the same or different?
same only.
Same, sir.
But what about the direction? At the top, it will be right side. What about at the bottom? It will be on the. See here. Here it is on the right side. That is fine. What about here at the bottom? It will be on the left side. So what is the direction at 2? Right side. But forces will generate on the left side. So what about K21? Minus 24. Now similarly, do it for K12 and K22. So what happens if you apply unit displacement at 2? How many columns are participating there?
2, sir.
Only 2. Look at the bottom story and look at the top story. If you look at the bottom story, 2. If you look at the top story, 2. So total how many?
4.
4 columns.
Then what about the stiffness then? If 2 columns are participating, then what is the stiffness you have taken? 24
Minus
EI.
44. Yeah.
Then what about if 4 columns are participating?
48.
48 EI by LQ. What about K12 then? Is this the same? Opposite to the direction, minus 24 EI by LQ. Do I need to draw or is it fine? If you want me to discuss, I'll discuss or we'll stop that.
Sir, kindly draw the deflected shape along, sir.
Just a second. K11, I don't think you
Ah,
should
yes.
draw, right?
Yes, sir. Yes, sir.
What will be the reflected share? If it is moves by here and if it is moves by here. So here the reflected shape will be. Here also the reflected shape will be, right?
Ah, yes, sir.
This is what delta and this is what delta. Now, if you look at this bottom story, obviously you can say here the force will develop, here the force will develop, and here it will be in the opposite direction. What about their forces here? 12 EI by LQ, right? Now, if you look into the top story, here it will, here it will develop on the right side. Here also it will develop on the right side. What about at the top? Obviously they will develop on the left side. So total how many? 1, 2, 3, 4. So 4 into 12 EI by LQ. 48 EI by LQ. Top 2. 24 EI by LQ. As these are opposite direction, negative.
Minus. Yes.
Yeah.
Yes, sir. Please.
So even for flexibility matrix, what happens is that, as I'm telling you, finding stiffness is easier in compared to the flexibility. So that's why even if somebody asks you flexibility, you do one thing, find the stiffness and then take the inverse.
Okay, sir.
So with this, I think you guys are okay with this method too.
Yes, sir.
So let's continue tomorrow. What do you say in the next class?
Yes, sir. Yes, sir.
Let's start a new topic there. Most of the important topics are over by today. From tomorrow, I'll just cover, just for the sake of it, I'll cover the remaining topics and we'll discuss the important topics in detail further, like theoretically or mechanically. We'll discuss the mechanics of some other problems on the coming classes. Arches, cables. I'll give you the introduction and we'll discuss with examination point of view only. And I think you guys might have remembered how much time that will take to solve the arches cases. There are some standard cases that we have to by heart, and there are some problems with logic we can solve with them too. Okay, we'll continue from next class. Solve these problems and let me know and share it with me if you guys have any doubts. We'll discuss that too on Friday.
Okay,
Yes,
sir. Sir, tomorrow you have class, sir?
We have another class Friday. You are hanging.
Okay, sir. Okay, sir.
Yes, sir.
Please solve the
Thank you, sir.
problems and please go through them and get a thought and come to the class. If you are not getting a thought, let me know.
Yes,
You
sir.
don't need to solve all problems. Just go through the problems and think about them. If you are getting idea, that's more than enough. If you are not getting, then let me know. That's what required.
Yes, sir.
Okay, sir.
Okay, then we'll stop today. Thank you.
Thank you, sir.
sir.